Hello, my name is Mario Roederer. I'm a senior investigator at the Vaccine Research Center at the National Institutes of Health. I'm here this afternoon to speak with Professors Leonard and Leonore Herzenberg, who are at the Department of Genetics in Stanford University, where they've run a successful genetics and immunology laboratory for 60 years. I did my postdoctoral training with Len and Lee, and I'm pleased and honored to be here to have a conversation with them about the making of their science, not so much the science itself. Len?
Well,
Lee?
it's going to be very interesting. And Mario was in this lab for 10 years or 12 years, something like that, before he went to the Vaccine Research Center.
It was a very productive time in my life.
Yeah.
There are a number of unique aspects of your laboratory that I thought would be very interesting for people to hear about. One of them, obviously, is that you're a husband and wife team and have been for a very long time. I wonder if you would tell us about how that came about and the evolution of Lee's role in the laboratory and how you interplay in running the laboratory.
Want me to start? Okay, so Lee and I really met when I was a senior at Brooklyn College, and Lee was recommended by a friend of mine to be tutored because she had a case of poison ivy, and she was falling behind a little bit in her math or analytic geometry, I think it was, or calculus, something. Anyway, so we decided she could come over to my house, which was walking distance to Brooklyn College, and there we studied, but we also played around, and eventually we fell in love, and many more things came about, including our getting married, including having children, and so on.
So it was an immunological reaction that brought you together originally.
Well, intellectual immunology.
It was more like analytic geometry. But it's okay.
So Lee, you followed Len when Len went to Stanford, to Caltech for your graduate work.
I did graduate work after Brooklyn College. I went on a National Science Foundation fellowship to Caltech.
He had one of the first National Science Foundation fellowships.
Yes.
They were very exciting at that time. They really started the whole support that followed after that for biology. It was great.
Uh-huh.
Yeah. But before I actually went to Caltech, there was a summer in between. And the summer, I belonged to an organization which we called the Society of Biology and Medicine. And it gave a scholarship to go to Woods Hole for the marine biology laboratory at Woods Hole. However, I didn't have to use that. I used the NSF fellowship to pay for that. And this good friend who introduced us together took the Society of Biology Medicine scholarship fellowship, so he was also covered. So neither of us had to pay for the summer at Woods Hole.
But Lee, you didn't start working with Len directly for many years, right?
No, that's not. I mean, I worked with him at Woods Hole. That was whenever I could get into the laboratory, he was in the laboratory full time, from the time he got up in the morning until the time he went to sleep at night. And I just hung out. I mean, so you don't just hang out, you start learning about it, you start working on it, you hold the pipettes, you mix the solutions, eventually you just basically do it. I mean, so it started back in Woods Hole. When we got to Caltech, I tried, he went a year ahead of me, and then it was too lonely and too expensive to be the other sides of the country, and so then I followed him the succeeding year. We got married. I was all of 18. How I knew I wanted to get married, I don't know. But I knew that I was with the right person. My parents knew also. And I think my parents had as much to do with making that marriage as I did myself. But when I followed him out there, I tried to continue school there at Pomona. But Pomona was teaching how to become a lab technician for women. And Caltech had Jim Watson and Matt Messelson and everybody, George Beadle. It was like one of the most exciting places to be that you could ever be. So after 6 months at Pomona, I decided that I was spending money to alienate myself from the environment I really wanted to be in. Now, at 18 and a half, I mean, we worked this out, and we figured out that wasn't the place to be. And I still, looking back at it, how we ever did this, I don't know. But anyway, I started I'd come home from school anyway, and the first thing I'd do would be to come to the lab, and I'd be there from, say, 4 o'clock in the afternoon until midnight when we went home, whatever happened. And the next morning I'd go out to school, and then I'd come back, do my homework at the lab. But there was things to do. There were experiments to be had. There were lots of great seminars. There were colleagues. Everybody would come in and talk about science. You talk about the kind of science that we did in our lab comes from that environment, where everyone knew what everyone else was doing, and whenever somebody had a new finding, they came in and shared it as soon as they could.
I want to add something that when I went to Caltech, when I came in as a new graduate student, I really wanted to do some lab work. And they assigned me to work in the laboratory that was part of Herschel Mitchell's laboratory. So I became sort of a postdoctoral fellow of Mitchell.
Predoctoral.
Predoctoral,
yeah,
predoctoral. And George Beadle was the chairman of the department of biology, and Pauling was there, and Linus Pauling. He was in the chemistry part of it. I was in the biology part of it. And Caltech was a very free, there were very few students, very few postdocs. And my lab partner that I was assigned to this lab that was Mitchell's lab, the lab partner on the other bench in the same lab was a fellow who had worked in, it wasn't the poison control centers at that point. It was, what was it? Later?
Al was in the Navy. Al was in the Navy. He had just come back.
Al Knudsen, yeah, who became very famous later on for doing many scientific things. And he was my lab partner on the other side of the lab. And George Beadle was his sort of mentor as the chairman of the department. And he was, 8 years older than we were, something like that.
Al was.
Al
George,
was.
yeah.
Al Knudsen was. And he had a couple of kids, young kids at that point. And we babysat these young kids for Al and for, I can't remember the name of his wife.
Paula,
yeah, there was Al and Paula, that's correct.
But they nurtured us a lot, and that was very helpful, I think, in a time when we were just kids from New York. I have no idea what Caltech thought of me at that time. I would love to understand that. As I look back, if I could see me as I was in that environment, this was a very cute kid. I was tiny, not like I am now, but very tiny, and just full of vivaciousness and jumping all over the place and really loving to go to the classes. And they eventually invited me to just take classes there. They said that's okay. And I said, okay, I would take classes there because that's what I wanted to learn. But they were only graduate classes. So I was a 2-year undergraduate, and I was taking graduate classes with Len's classmates.
Yeah,
and it didn't really occur to me that maybe I shouldn't dare to do such a thing, because they were intellectually far better trained than I was.
It was a fantastic place to be with all those future Nobel laureates,
That's
seven or eight Nobel laureates in that group. And one of the people who was that you interacted with was Barbara McClintock, right?
A little bit later on.
Yeah.
And she was a woman in science, which at that time was fairly unusual at that position.
Yeah, but she already...
Fairly is not the word. Very.
And Caltech didn't accept women either as undergraduates or graduate students at that point. And so Lee was was a what were you called? You were auditing basically.
Yeah.
And the professors said, well, she could also go to the laboratories and she could also take the exams. And they gave her letters from the exam saying that she had done, as she did, extremely well.
All
and that
A's
turned
but
out
one
to be
B.
very useful later on when we went after Paris at the Pasteur Institute. We came back to the NIH, where I was a 2-year wonder. Oh, it turned out to be a 2-year wonder, and that kept me out of the army, and I carried a pipette for my country. Lee, Lee and I found together that Bruce Ames, who had been at Caltech a year or so before me, had a place for a GS something 8, I think, position, and so he hired her to do this, being a technician, and then he promptly went off to St. Louis, where Arthur Kornberg and his whole team were, I don't know, was or were.
So this has been a long battle for both of you to support Lee as a leader in science, as a scientist, because there was this tremendous bias against scientists and women, something that to a certain extent still exists. What was the battle like even when you came to Stanford, which was a fairly liberal institution even at that time? There were still hurdles that had to be overcome. Has it been a frustration? Has it opened doors for?
It's a good question. Even try to remember back. You have to remember into a different world. We were in France. Remember, Monod, when we went from Caltech, where I was really welcomed, and I was allowed to take the classes, even though the school didn't allow me to. I was treated like a student, and they had the same expectations for me, which was great. And that they did this started me off in that direction. When we got to Paris, I was just newly pregnant, still morning sick. And Len said, well, now you can go and do the painting and be the painter that you always, because I love to paint and I like to write and do all this stuff. And I said, I don't want to do that. I don't want to do that. I just want to come to the lab with you. So Jacques Monod said, well, you're very welcome in the lab. And being France, there were women scientists in the lab at that time. It was not a shock for women to be in the lab. Mostly they were technicians, but the technicians were very well treated and very, participated a lot. In
some of them were very good scientists, though.
Yeah.
And
Madeleine and some of the others. So,
yes.
But Monod did not say, the men stay here and the women stay there.
Yeah.
That happened at Cambridge later on.
Yeah,
That's
later
another
on.
story.
But it was important that Monod, Monod's mother was American.
His mother was American. His wife was the head of I think, the Asian Museum in Paris. She was the head of one of the major museums. And he did not see women as second-class citizens. And Monod did a lot with me. I mean, he would talk directly to me all the time about things. And one day he said that you can't grow E. coli. You can't grow any organism. There's no organism that would grow on a thiogalactoside. And that just tweaked me. So I went out and I took some dirt and put it in a flask and put in thiogalactoside, which was what we had in the lab, and put it in the dark in the closet. And 2 weeks later, I opened it up and opened up the top. Look at that. They're growing. Jacques, look.
Smell.
Guess what I did? Before that time, we never had to sterilize any thiogalactoside solution.
Because nothing would grow on it.
Nothing would grow on it after that. I did it.
You stunk up the lab.
Stunk up the lab, and made it so we had to make all our solutions and autoclave them. But that was great. So the baby was born there, and they didn't mind that we brought the baby in, and she sat in a carry cot up on top of Len's desk. I would come in, mid-morning with her and hang out until it was time to go home. So it was a welcoming environment in France. I mean, and at the table, we were both at the table at lunch. Lunch, I guess, for a more broader audience, lunch consisted of the 10 scientists or so in our group, which was Jacques Monod on our floor, Georges Cohn, François Gros. All of these people became heads of whatever in France. And upstairs was François Jacob and
Elie Volman
and André Leboeuf, who later Nobel Prize winner people. So the whole place was, that was lunch. There were 12 of us, or 10, 12 of us sat at lunch.
Yeah, but we'd all go out to the nearest.
We didn't. We ate in the cafeteria there. Do you remember we had that
no,
table?
it wasn't a cafeteria there. That we brought in our food. Remember?
Yeah, it wasn't a cafeteria. It was we had a lunchroom.
Yeah.
It was a glass top. Remember, this was
Yeah.
Pasteur Institute, and Louis Pasteur's big wine vats were actually stored at the back of this glass-topped atrium, and so because they had natural light, which they used, so they had all glass-top science buildings, and. Anyway, the group of us would sit at lunch, and half of lunch was science, whatever the latest finding is, whatever the latest theory was, debating. This was debating, well, never mind what the science was, but it was the latest stuff that they ultimately, right after the year after we left, they got the Nobel Prize. So, but more than that, it was politics. And that's the other side of life, and that's where all of this began. That talk range from
World War II came just before that. After all, this was only a few years after the end of World War II.
Right.
It was 52, and World War II ended in 45 in Europe. And Jacques Monod and several of these other people were in the resistance during World War II,
Did those conversations spur you to become politically active? Because in your years here in the United States,
we
you
were
very
already
politically active.
at Caltech. Matt Messelson, George Streisinger, Linus Pauling were part of the group that we were part of, and we volunteered at Linus's house to, as kids. I mean, we lugged the cases of soda and set the tables and cleaned up afterwards when they had political parties and things like that. So, but we formed a chapter, the Federation of American Scientists. That's where our whole connection with the organization. And I was very, very active in that. I'd grown up in a neighborhood where politics was politics. I grew up in Brighton Beach before it became a Russian center. And it was before that there was an immigration wave that changed things. But when I was in Brighton, it was very political. I mean, people walked down the street and talked to each other about some latest political thing. Did you hear that so-and-so had done this? Strongly democratic, Roosevelt supporting, a thread of the Communist Party through there, a lot of labor activists and union activists.
And then at Caltech, you were directly experienced the McCarthy era, right?
Well, yeah, the McCarthy era actually began when I was still an undergraduate applying for becoming a graduate student. And I remember I was with my mother in the kitchen, and where McCarthy was fought by Eisenhower for the Army, and McCarthy was a senator, and he was a very terribly conservative senator, radically conservative. So it really began there. And I got this NSF fellowship, which allowed me to go to Caltech. And as I said, the NSF fellowship actually was given out at that point because of Sputnik. Sputnik was the satellite that the Russians had sent up. And
I'm not sure if that's right.
I think it is.
So so at Caltech, though, there were didn't Linus Pauling have problems because
Yes, Linus Pauling's visa was not allowed by the State Department because he was in favor of, this was a little bit later, but he was in favor of blocking nuclear testing and nuclear bombs, therefore.
That was happening at that time, and it started at that time. But Martin Kamen's visa was blocked. Martin Kamen was another well-known biologist.
He was a biochemist at San Diego at that point, and
then even when you were here at Stanford, you saw still the remnant effects of the McCarthyism because of the, what was it? A UC system required all of the professors to sign.
Correct.
Non-communist.
They had to sign
loyalty oaths.
Loyalty oaths, they were called.
Right.
And many of the professors were at Berkeley which was UC Berkeley, University of California, Berkeley, they refused to sign the loyalty oath, and the Stanford benefited from it enormously. So the people who were going to Berkeley instead went to Stanford, like Letterberg, who was the chairman of our department.
The whole physics department from Berkeley picked up and moved here en masse as a department. It wasn't that people were disloyal. There was a feeling that the government doesn't have a right to ask you to sign when you are, as a citizen, already loyal. And the argument was really the loyalty oath. It was not the issue of whether or not you were loyal. And Pauling didn't want to sign this, and then McCarthy came in with his famous "Have you ever" or "Have you ever been a member of the Communist Party or any other group that was this, or any group affiliated with this?" And you could never answer that question because you never knew whether sometime they were going to unearth some group and say, "You said you never were," and well, I didn't know that the Daughters of the American Revolution were actually a Communist Front organization. I mean, you couldn't know by what organization said anyway. So it was a legal man trap. But McCarthy's idea was really basically a political one that he drove. George Beadle was forced to fire the stock department keeper, a man named Paul Orr, actually. And he was forced to fire him because Paul Orr had some affiliation with what would be known as an actual communist group. He wasn't not a member of it, but he had some affiliation with it. But the whole story was a story of people hiring or firing you on the basis of what your past political activities were, not what you did in your job or what you were doing.
And then you continued to be politically active through the 60s with the Vietnam War.
Yes.
And following beyond that.
And fallout shelters, which when we came here, the first thing we did, there was a big attempt by the government to prove to you that you could dig a fallout shelter in your backyard, put a roof over your head, and in case there was an atom bomb, you could crawl down into that and then have enough supplies for a week, and then when you came out, you would be safe. And we really tried to explain to people that if there was fallout on the ground, it was going to be months and months, and that you couldn't live yourself in this. And eventually,
this was a time of JFK, John F. Kennedy.
Right.
Yeah.
You know, before he was shot, but he was in favor of building these fallout shelters.
And then, ironically, the measurement of fallout underlies some of the technology that eventually became flow cytometry.
Yes,
so
correct.
There's a big circle here, but we'll come back to that a little bit later.
Yeah, we have to come back to that. It's a good story, actually.
It's a fun story.
But knowing about radioactivity was something that we as scientists knew about because we were already using radioisotopes. And at that time, we used them in very small counters that you actually sat and fed the counter one tube at a time. I mean, horrors for what we were exposing ourselves to.
The political activism was very integral in various parts of your life. Mm-hmm. Do you think that's colored your research, or what's the interplay between the way you ran your research program or the projects you did, the people you brought into the laboratory, and the politics?
I think it was. I think it was a lot. I mean, the reason we went to Paris, to Pasteur, was because Jacques Monod was had been in the resistance during World War II. And so we were attracted to go there, and he was happy to get us to come because we were liberals too, very liberal.
It's a very good question, actually, Mario. I think that the politics certainly colored our associations. When we were at Caltech, there were the whole bunch of us who were all Federation of American Scientists members, and they were the leading people at their time. There were people that we didn't hang out with.
Can I interject? Before it was called the Federation of American Scientists, it was called the Federation of Atomic Scientists.
That's true. Yeah. So all that stuff ties together, and our interest in it. But I think it's fair enough to say that our social interactions were also colored by our political thinking. So the people who hung together, and the political thinking. There was the question of what we're going to do about this guy in the department who was being fired. There were questions. There were a few people in the department who hung together and were probably more right-wing. I hardly remember them now. Most of the active forward-thinking scientists were forward-thinking in all of the issues. I mean, they believed women should be admitted to Caltech. Most of Caltech was horribly conservative. It was engineering, and it was a whole other side of the world.
Physics
and stuff. So there were people. Richard Feynman was there at the time. It was generally thought that those people who were good scientists and bright hung out with the liberal group.
Right. Do you think it's our role as scientists to be politically active or to advocate on behalf of science and health?
I think that, yes, the answer is yes, that it's important that scientists who know an awful lot about medicine and recombinant DNA and dealing with genetic sequencing and so on to this day, that it's still the liberals who are very much involved in that, and it's the Republicans who are blocking so much of it. So the NIH, the support for research, so much of it comes through the NIH.
How would you compare the environment now, not just the funding environment, but the support of science at the congressional level or at the administrative level, compared to, say, 20 years ago or 40 years ago?
Support for science now. I was saying the other night that I think that part of what's happened is that we've been forced to work so much harder to get support for science now that we don't have time for this, and that was not an unintentional result of cutting the funding in science. If you go back to the Reagan era, there were whole discussions of this, and Reagan himself saying that they've got too much time to do these things, to think about politics. They should be working harder, and we're too liberal. We're giving them too much money. We're allowing them to have time to do this. I don't know what that took out of my time. Maybe 10% of my time away from the lab. Mainly it took it away from the sleep and the family, because lab had to go on, science goes on. It's a 18-hour-a-day operation, so that didn't stop. So, but right now, we've reached the point in funding for science where I think we're destroying science, and I think that it will take 10 or 15 years to work through the findings that today's scientists have already made up until today. And there will be some more important findings that will be made, but for an awful lot of it, it's going to be just working out and integrating what was found, and then there's going to be no new garden to grow. That's what's really missing is the support for people to do something that nobody thought would work.
One of the things I found remarkable when I first joined your lab, which was already a quarter of a century ago, was the number of eminent scientists that I would read about who had trained in your laboratory, who had trained with you. And it was really remarkable to see the litany of people who've come out of this laboratory and gone on to become fantastic independent scientists. So for people who are starting their own laboratories and are tasked with trying to figure out what postdocs to bring in or what students to bring in, what's the secret? How do you identify those people?
Nowadays, it's the big labs, which we were a big lab. I had for 14 years, renewed after 7 years, I had what was called an Outstanding Investigator Grant from the NIH, which allowed me every year to say what I wanted to work on. And I could bring in people who would work on these projects and support them.
So it was the long-term funding view taken by NIH through the OIG that
Absolutely.
allowed you the freedom to hire excellent people and let them do...
It was.
Yeah,
of course, the OIGs, the Outstanding Investigator Grants, are now gone,
Right.
and it's very, very difficult to get grant support for Lee's work, for my work, for the work of my postdocs or graduate students or medical students.
Yeah, if somebody took a good look at those OIG grants and looked at what was produced during the time of those grants, the facts is definitely, without the OIG grant, it would have been very, very hard to do, to build the facts. So everything we're using the facts for, and I mean, I think most of the people seeing this would know that what the facts is used for, but just for your benefit, even for their benefit, that it's between using it for diagnosis of all the cancer diagnosis, all of the HIV monitoring,
autoimmune
disease monitoring of all kinds,
diagnosis monitoring,
whatever, all of those things, and then the stem cells. And there we have to go to the fact that Irving Weisman also had an OIG grant. And we would not have stem cells today if Irv didn't have the freedom to go and do if any of us had to prove to study sections every 3 years what it is that we're doing, this would really be a mess. And these grants they used a very good panel of people to judge who was going to get them. They were outstanding panels, and they really worked. I mean, this is basically what made science what it is today, and I'm sure we can find 4 or 5 other OIG grants that were used similarly.
Yeah, Hugh McDevitt, who was very important here. We said Irv Weisman. But people like Hiro Nakauchi, who was in our lab from Japan 25 years or so ago, and he's now coming back.
We hope.
We're helping him to do this with Irv Weisman again.
Yeah.
Because there's state money, not just federal money.
So the people that brought into the lab, it was, having been in the lab for many years, it was much more of a family environment in a sense than any other laboratory that I've been in. We had journal clubs at your house on Thursday nights at 8:30, which was late for many people, but it was a wonderful time because we would sit back, we would have a glass of wine or a glass of beer, and it would be an open forum for discussion. That's a journal club that goes way back, right?
Yeah, yes. Yeah. It doesn't exist anymore. This is one of the things I'm hearing from all over, that the computer has kind of destroyed a lot of this, because you take your computer home. It's become like video games. They're social, but in a very different way.
Yes. And I see that when I read about your times at the Pasteur with Jacob and Monod, and you said earlier about sitting around at lunch and listening to these eminent scientists have these discussions, and then the journal clubs where you have these face-to-face discussions in a more less science setting, a more
formal.
personal session, personal setting. I think that's very useful, and that's certainly something that you espoused, and the society that you create inside the laboratory is very important.
I mean, I would still like to do this. Again, money.
Right.
If there were enough money to bring the visitors that we used to bring, but there isn't. So the lab, we still have our regular Monday lunch, well, it's Friday now, but whatever. But we still have our regular lab meeting as we always had, and that's kind of sacrosanct, everybody produces, but it's a smaller lab, and now we try and join up with some of the other labs here at Stanford and have joint meetings and stuff. But there's no money to do the traveling with. There's no money to do other people don't come traveling here. Plenty of people come, but really people don't come, and they don't spend the time. Roy Riblett is back in the lab. Remember, Roy was one of the very first students. He was the first one to get his graduate degree with us, and he now comes up here regularly because he has to come up here for family reasons, and so he sits in the lab when he's here, and now he's become part of the lab. This is great. If we had money actually to pay for him to be here all the time, that would be great. I mean, so much of it hangs on the availability of money. I really hate throwing it back to that, because money has never been the driving interest.
Right. But to fund the face-to-face meetings, and I think another key part of your career has been the sabbaticals that you did. The sabbatical that you did in Cambridge, and later you did one at Pasteur. Can you talk about how the sabbaticals you took, how that influenced the development of the science and technology? And
Well, the only sabbatical I really took that was relevant was at Pasteur years later.
Caesar.
Well, sorry, in England, Cesar Milstein.
Right.
And he his philosophy was to keep things very much into himself, or at least for the English. In fact, it was editorial in Nature saying that American scientists are set to take advantage of the English findings of making hybrid antibodies. Actually, we were the ones who, Lee and I, both went to a party with Caesar, and we said, why don't you call these things, instead of just hybrids of B cells, call them hybridomas, because they really are hybrids of tumors, which is oma, and of normal cells, spleen cells or lymphoid cells. So we named actually.
You coined a hybridoma.
We called them hybridomas.
Yeah, it was at a New Year's party at the Cambridge Club, and we went with Caesar and his wife and a couple of other people from the lab, and we got into discussing things. And Lee, being ever since what Lee is, said, Caesar, we have to name these things. It is ridiculous. We can't talk about them. Let's give them a name. So he said, well, I don't know what to name them. So we threw out 2 or 3 names, and I threw out hybridoma. He said, I like that. So they became hybridomas.
But this was, I think, a key technology that you brought back to the United States, the hybridoma technology, because that underlies virtually all of biotechnology nowadays, right?
Yes.
The specificities brought by monoclonal antibodies allows us to do bioassays. It's in therapeutics. It's in every assay that we do every day. And this was in 1976, 1977. You brought the hybridoma technology back?
Len understood this. I remember this well, actually, and Len understood this stuff. Roy Riblett was asked to do, as part of his graduate work, to do a hybridization very much like what Milstein did. And he took the data, and it was rolled up on a tape. Remember how we used to get tapes off the printer? It was rolled up on this tape, and it sat in his desk drawer on the left-hand side of the desk drawer. As he pulled it out, his desk was against the wall in the lab opposite the office, the one that Charlie used to be at the same area. Charlie Shue. And I would come in there, and Roy would open the door, and I'd say, Roy, you ever going to compute that? And he said, I'm going to do it. I'm going to do it. I'm going to do it. He laughs now. He says, I left my Nobel Prize in the desk drawer. He knew that it had worked.
Right.
He'd looked at the tape. He knew it worked. And he didn't want to be pushed into doing a different project than the one that he was doing, because he was going to finish his degree finally. And he felt it would be a distraction to do this. So he actually had done the same hybridization that Caesar had done. Len heard Caesar had done it, and Len was interested anyway in learning molecular biology, because we really didn't know very much molecular biology at that time. And so he worked out for us to do a sabbatical with Caesar at
Mill Hill. No, not Mill Hill. Sorry, the Medical Research Council.
MRC in Cambridge.
In Cambridge.
So he worked out for us to go there and do that, or rather, he worked out for himself to go there and do this. And then I said, well, what will I do? And they said, well, Caesar says you can work where his wife works, which is in Baberham.
So a nearby town.
Okay, we're going on sabbatical with somebody Len wants to work with, but I figured, like everything else, I would be able to work in the lab with Len and nothing. Well, Caesar absolutely would not have me in the lab. I think I walked into that lab room maybe 10 or 20 times during the whole time we were there. He just would not have me be there. Nor would he actually have Len in the lab, strangely. Len talked with everybody at Mill Hill and did a little bit of work at MRC. Did a little bit of work with this, but spent much more time talking to other people. Caesar had a guy there who was working on the hybridomas, and he had developed actually an anti-IgD, the famous anti-IgD. But he wouldn't let us work on it. We said, but we heard about it. We said, Caesar, the best way to look at this is to look at it with the facts. We could look at it, we could really see what it does. We could use it as a staining reagent, etc. Caesar would have none of this. He said, it's not for that purpose. It's here for basic science. I'm not doing this. I want nothing to do with this, basically.
Yeah. I'd like to interject right here that it was then that we were working at Stanford still with a guy who was a member of the department, Vernon Oy, who
he was a graduate student.
Was a graduate student, and he was working with Bunny Koshland. I've forgotten her first name anyway. Marion Koshland, who was called Bunny at Berkeley.
Dan's wife, for posterity.
Dan Koshland's wife, and she ran a very conservative laboratory where people just kept their own findings and didn't interact with other people. And Vern knew that he interacted across the board because he'd been in our lab. So he gave up and he was also getting divorced from somebody.
And he was unhappy. And
he was unhappy.
Missed us, and we left. He was the only graduate student who was floating around. At that time, Dick Goldsby and Barbara were in the lab. I mean, there was a good, solid group working in the lab. Pat Jones had come back and was working there. So the lab was working well, but Vernon was kind of at sea. So
so I said, why don't you come to Cambridge, where we are, and you can actually stay in the apartment that we had gotten, but there were more rooms in it than we needed to use. And so he came, and then we made hybrid. Milstein was having a problem with the hybridomas weren't working because there was some kind of yeast infection in the cultures, and so we worked out in Babraham, which was where Lee was with Milstein's wife, and we made the hybridomas there, and we read the results on the cell counter or the radiation counter, whatever, and we took this little motorcycle back and forth, and
Vernon got a motorcycle, and he and Len would ride out on the motorcycle.
Club by bike.
Yeah.
But I mean, Caesar quite happily gave us the material.
Right.
Okay, he did not hold on to it, but he really, I don't know if it was quite happily. I never did figure that out. He was a strange guy. I once had a discussion with him relevant to what we're talking about here. And the discussion was, okay, Caesar, suppose that I know something that I could continue to work on, and you know something you could continue to work on, that those two things put together, if we told each other what we were doing, would allow us to cure cancer in 5 years. But if we each do it ourselves, it might take us 10 years to get to that point, and only one of us might get there, or maybe we both get there, or whatever. Which do you think is preferable? I mean, my answer was clearly, you would pool your information and get there in 5 years, because this would be people's lives. No, Caesar said, do it separately. Each person should do it separately, then you know what they've done. And he was more interested in knowing what he'd done. And we were basically less interested in knowing what we've done than in getting lots and lots of things done. And so sometimes when we talk old stories to people and say, oh yeah, we worked on that, we contributed that, we did. It's amazing all the different pots that we've stirred over a lot of years.
And in fact, I think an epitomic example of that would be when you came back from Cambridge and you made a series of monoclonal antibodies to the original CD8 and CD5 and allotypes and isotypes, and all of those hybridomas and antibodies you shared fully with whoever asked for them.
Correct. That's absolutely correct, Mario. But it's also part of that there was another guy.
Well, let me finish with Caesar. The lore on this, which you probably don't know, but at one point, Caesar had the anti-IgD, which, because we were giving out all the other antibodies, he basically had to throw into the pot as the anti-IgD. And he accosted me over this one day. I mean, he and I like Caesar, and we got along. He's an interesting guy, but we really had very different philosophies. And so he accosted me today. He said, you had no right to give out those hybridomas unilaterally. You made a unilateral decision to give out the hybridomas. And I said, well, we made the hybridomas. We always share everything we're doing. He said, you had no right to do that. And I never did quite understand what he wanted by multilaterally, that we would have a big conference and all decide to give them out. It could take us another year to do that.
It would just slow
It
things
didn't.
down.
Yeah, it really didn't make any sense. Baruch Ben-Asaref, on the other hand, actually one of the few compliments I got from Baruch Ben-Asaref was, you guys did the right thing by giving out these hybridomas. It really made the whole difference. The difference really for other people who are listening is that before hybridomas, the use of the fax was a very catch-as-catch-can operation. You could stain cells, but I had one, conventional antibody which I got by bleeding 7 mice and pooling them together, and you had another one bleeding 7 mice, pooling them together. Yours could be different than mine. The meetings were meetings where we not only argued the meaning of the science, but we argued whether what your antibody saw was the same as my antibody. And then somebody would finally stand up and say, okay, let's get the two antibodies together. And the technology wasn't even possible, and by the time you got it all together, you had no more of the antiserum. So Len saw this immediately. He recognized this when we got to Cambridge, and he realized that the hybridomas really were there and that you could make them. He immediately called Eli Surkars, and they set up a meeting at Park City, I guess it was. It was one of the ski places.
One of the ski places.
And we added a session onto that program on hybridomas, and we invited Cesar to speak, and I believe he came.
And we also invited Klaus Rajewski.
Klaus Rajewski came. It was a very important set of people who were there, and we all talked about the use of hybridomas. Now, at the same time as Len was doing this, he called Bernie Schur, who was then head of Becton Dickinson. And Becton Dickinson were the people who were making the flow cytometry instruments. And Len told him that, Bernie, these are going to be fax reagents, they're going to be important. It took Bernie 18 months to convince the management at BD. What's new? It's still the same story. But it took him 18 months to convince them to move into this new technology. But finally they did, and they hired Chuck Metzler, who was one of our alumni, and later Noel Warner, also one of our alumni, to really build the whole concept and to teach people, because teaching people that hybridomas were better than goat antibodies was a major, they were quite convinced that goat antibodies was the way they were going, and they had made a corporate decision that these were correct, and no amount of science was going to convince them otherwise. But ultimately, that's how it all grew. And it was all right before Christmas that year, or before the winter in any event, that Len really spent a lot of time explaining to people why hybridomas were really important, what you could get out of them.
And other people started making hybridomas, but they weren't quite as generous in terms of sharing them.
That's true. But we also had meetings galore in which people got together and talked about the future of antibodies, monoclonal antibodies from hybridomas, but people were not sharing them. But Bernie Schur, actually, bless his soul, was very generous, and he also found people who were making hybridomas or monoclonal antibodies or antibodies from Sloan Kettering. There was a guy by the name of Robbie Evans.
Robbie Evans, yes, who made the human ones. The first human ones were made by Robbie Evans.
Yeah, and so Bernie said, well, what can he do to encourage him? I said, well, give him one of your faxes, one of the faxes that we've made, and let him test them on them, and have him send us some of the antibodies to test on the faxes we had. And we did that, and that generated not only CD4, CD8, and many other the monoclonal antibodies we now know about very much, and many of the human antibodies.
Well, Jeff Ledbetter had characterized the mouse ones in our lab. So when these came up, Robbie eventually brought them out, and we were having a grant, one of the grant reviews, where the grant committee comes to site visit.
Site visit.
And we were having a site visit that day, and Jeff was in the fax room when he tested these first things, and somebody came and got me and said, "You better see Jeff." And I said, "What's the matter?" And Jeff was, he was really having a hyperventilating. He said, "They're exactly alike." He said, "I can pick out from these humans exactly from the mouse what these are. I've got anti-CD3, I've got anti-CD." We didn't have 4. We had anti-CD3, CD5, and several others. And he was just so shocked by what he'd seen on the screen, because they really have the same phenotype. And he, of course, did this correspondence between mouse and human stuff, and he did the biochemistry. So it was knowing how to do the work. I mean, we had people who really knew how to do the work and who taught each other everything in the lab. There was no such thing as I have a technology. You know this very well. But
so let's talk a little bit about the king of biotechnology, which is flow cytometry, right? The original biotechnology, as you've referred to it, which is correct, it's one of the original biotechnology instruments. What drove the original need, or how did you foresee the need for biotechnology?
Len has very bad eyes, as you know, and he hated microscopy. And we were doing microscopy with these not monoclonal antibodies, but regular antibodies. And the way that people were deciding that this was a B cell and this was a T cell was by having something that pretty much the antibody reacted with immunoglobulins, and this antibody reacted with something. We didn't even know there were really T cells, but Thi1 was the key antigen. And people looking down microscopes and saying that there are 55% of these cells in here, and 30% of those that's named green with that, and these are red. And you're getting all these discussions, then you're getting fights. And various people would say, well, I saw that there were 80% of those, and they were both on the same cell. And other people would say, no, you really weren't seeing right. And you get these ridiculous arguments. Ultimately, Max Cooper and John Carney were considered the authorities. That, if John and Max said they saw something, that won. But it was horrible. It was like, and for Len, he was out of the club, because he could not deal with the microscope, and we had no other way of quantitating what was in a cell suspension. You take an organ, you have it, it's got 1 million. Now we know how many different kinds of cells there are in spleen. They would take a mouse spleen and make a suspension out of it, and they couldn't. It was just chaos, and we knew it was chaos. It was not science as we wanted to do it. So Len basically said there ought to be a way of counting these things and of measuring the amount of this marker that's on the surface. There ought to be some way of measuring the fluorescence. He heard that at Los Alamos that Matt Fulwiler and what's his name?
Another scientist, and I can't remember his name right at this moment, but I'll come back with it.
Anyway, he heard that he had a way of passing cells single file past a light source. And they were basically using a Coulter orifice and seeing the cells go past it. And so he said, I'm going to go to Los Alamos. This is 1961, roughly. I'm going to go to Los Alamos, and I'm going to ask those people if they would add fluorescence detection to their stream so that we could actually count the number of red ones and green ones. Len went there, and do you want to pick up the story there, or do you want me to continue?
Well, they told me there, this was Los Alamos Biological Laboratory people, and they said, well, it's not our mission to do that. Our mission was to measure fallout, basically.
Radiation fallout.
And but he'd taken a slight side. So Fulwiler had taken I can't remember the name of the other guy. Anyway, Fulwiler had worked, gotten a opportunity to work with a fellow scientist in Colorado, in Denver, wasn't it? Yeah. And I said, well, if you could give me the plans for what you've got, I can try and duplicate that at Stanford and do fluorescent activated cell sorting, which is what we called it by then. And they said, sure, we'll give it to you. And I took the plans back here, and I found several people who were working for Lederberg in instrumentation research laboratory, and I got them to make another machine like that. And I told them what the requirements would be, and made sure that they looked at enough cells and so on and so forth. And then out of this, that's when Bernie Schur came in, and he was always looking for results that were happening at Stanford, since he'd moved out to near Stanford to Atherton, and he licensed. He took a license on this finding.
Bernie came looking for some other kind, an immunomeasuring technology, which was not very interesting. I forget which one he was after.
His son-in-law.
Of some kind.
He had a son-in-law.
It wasn't a son-in-law, but it was a David. Yeah. Anyway, a company son-in-law who was with him, and he came to introduce him, and they were trying to do some immunoassay. And Len, I remember this. Len said to him, "If you really want to do something that would be valuable, you would license this machine that we're building." And by that time, we had built the whole thing. We had actually put cells through it. We knew it would work. He said, "You could license this and build commercial versions of this, and this would be pretty good." And there was a discussion. The question was, how many would sell? Would it be 10, or do you think we might actually sell 30?
Instruments.
And if you have any idea, there are now 30,000 of them or something like that. And there's many different companies making versions of them, etc.
What I find particularly remarkable is that, in principle, the basic technology has not really changed that much over 45 years.
Yes,
Right.
It looks, it's much more spiffy looking, and there's much better electronics, but the basic physics and process of the flow cytometry is exactly the same as it was when you built the first one, just in a different building here on Stanford.
Yes, correct. When let's see, I forgot which war it was. When the Suez crisis came, Suez Canal crisis came, they cut back. And this is the same. No, how did we get Dick Sweet?
Well, it was one of those crises. It wasn't the Suez crisis.
Funding crisis, and the company he was working for, Varian, I think it was going to drop the project that we'd started at Stanford, and I called him up and said, "Dick, how would you like to work with us instead of at Stanford rather than at Varian?" And he said, "There's nothing I'd like better than that." And so he came over here to work with us and was the key.
So Dick Sweet had
Bernie.
Dick Sweet had the patent on the inkjet printer.
That's right.
That's right. And so it's roughly the same technology of depositing ink drops.
It is the technology. They used his inkjet. Fulwiler was using Dick Sweet's inkjet design to deposit the cells, right, to charge the stream and move. So when you found a cell you were interested in, you could move the stream and sort it. They used Sweet's design. And so Len talked with Sweet while they were building the machine here, and then Varian took an interest and said they thought they might build the machine. Then they were cut back. And this is the standard thing. This is why things like this don't fly in corporate places, because it was obviously a 6 or 7 year effort at least. And somewheres in between, somebody's going to change hands in the corporate world, and that's what happened. And so Len was just devastated over the fact that Sweet was going to go somewhere else and do something entirely where he couldn't pay attention to the project. And so that was when you decided.
But I got Lederberg to allow the instrumentation research lab people with whatever his name was.
Lee Hundley and
yeah, but also who was the head of that group?
Elliot Leventhal.
Elliot Leventhal, yes.
Yes.
And there's now Leventhal Laboratories.
Speaking of funding, you'll find if you go to the archives for the Mars Shot laboratory, the I forget what they call that laboratory here, Elliot's lab. It was the bio something or other design laboratory.
It was for NASA.
It was a NASA project. If you go and look at his reports, they built the cell sorter. They thought of it and they built it. I mean, it wasn't that he was stealing credit, but his reports came out because his people were actually doing it. And he met with his people, and he kept that engineering effort moving. And he was an important part of that in that sense, that he drove this. Len, who was not an engineer at all, and had started because he knew what it needed to be. And this is, again, another one of the problems with biotechnology these days, that, or ever, that the engineers get together and they talk about what they think they can build, and then they build it expecting that some biologist is going to use it. And the real answer, as we know over and over again, is that the biologists have to drive this. And so I remember one time in particular when Len went to a meeting, he came back and he said they can only make it go 10 to the 6 cells per minute. I don't remember what the number was, but it was something like that.
1 million cells per hour.
1 million cells per hour, maybe it was. And Len just said to them, well, if you can't do that, and they said, well, you'll have to defy the laws of physics. We can't do it. And Len said, well, if you can't defy the law of physics, then we can't run the project. It is of no use for you to continue, and that's the end of the project. And so they all went back to the drawing board, and they figured out a way to make it go faster. It was a crucial turning point of this, and they really were quite certain that it could not go faster than that.
But what also happened during the same period, so I was on the genetics study section, which is a part of the NIH, which reviews grants, and I gave a talk to the people here at Stanford, and they got into a sit-in then, which involved David Parks and others. And then I went off to the study section meeting in Bethesda, and the sit-in went on, and out of this came continued work on the facts, cell sorter.
Yeah, it was a lot. There's a great deal of confusion. I know what Len's referring to, and there's a long history in there that involves Steve Ela, whom you probably remember. Yeah. And what was going on at the sit-in and information. But the sit-ins, again, these were social events. People were sitting in a building, but what did you do? You had all of your colleagues were there, so you sat in, and you also had discussions, and the discussions involved other people from other disciplines.
And you put out newsletters.
Yeah, it was extraordinarily cross-disciplinary, and it was a very great ferment. But I think we should take a funny break for a second from all this history to just talk about the history in terms of sit-in. Shockley was, at that time, the physicist Shockley was arguing that eugenics was correct. And he had figured out how eugenics was correct. And Letterberg was writing against Shockley. All the genetics department was saying, what is this guy? He's a physicist, he doesn't know what he's talking about. And he was talking about this. And so we come to the sit-in. And Len had a habit of opening the sit-in, coming to the front door, and then saying, sorry, guys, I got to go leave. I've got a study section. This would happen again. We said we knew when the sit-ins were going to be. We just look at Len's study section dates. But anyway, he got to the door of the sit-in. I mean, we would never, we never were in the vanguard of people. We were the chicken soup brigade. We were never in the vanguard of anything that was big in terms of civil violence or anything. But this was a sit-in. We were coming to deliver a message to the president that we were going to have a meeting. We were formally inviting the president of Stanford to address this meeting or something, which of course he was going to say, get lost. But everybody comes into the office, and it happened that Shockley was sitting there, and he saw an opportunity for an audience, and he started talking about his genetic theory. And Len comes up and starts debating him. And finally, Shockley is finding himself pushed further and further back against a wall. In a very gentle debate, but a debate. Finally, he says, I'm Shockley. And who are you? And then, who are you to argue this with me? And he says, I'm Len Herzenberg. I'm a professor of genetics. Broke the whole thing down. It was a great time. But these were things, and the students were all treated to this. This was part of being in a sit-in. This was the idea of sit-ins that people have is really just so different from the intellectual part of them that we have.
They were called teach-ins by that time.
Teach-ins, there were sit-ins, there were everything, and a lot of great people.
So during this time, and you mentioned Dave Parks and Dick Sweet and so on, you maintained a laboratory and research group that was comprised not only of biologists, but you had engineers and physicists and electronics engineers. And this is a mixture that you maintained for decades.
Yes.
And in fact, you still have
Yeah.
some of these people. So what was it like to maintain a lab where you had to interdisciplinary teach, engineers and physicists how to do biology and the biologists how to do engineering? How did you get them to talk to each other?
Well, it was great. So Dave Parks, was working on scattering, light scatter, and he became a friend of ours. And then we have Wayne Moore, who was still with us, but at that time
Where did we meet Dave Parks?
we met Dave Parks at the sit-in.
That's right.
Yeah.
We met. He was a physics graduate student. His wife was doing her degree in biology, and he loved both biology and physics. And he became a very close personal friend and political friend before he became involved in the actual flow cytometry stuff. He was hired in. He knew he wanted to do something in biology, and we hired him to come back.
And I think arguably Dave Parks knows more about flow cytometry than any person on the planet.
I think that's correct, yeah.
I think he would be flattered if you said that, Mario. Probably nobody else in the world would. But I would, since you have a camera here, if you're willing to take your camera up onto that wall and look at those two butterflies on the wall, can you do that?
Dave is quite the
Those,
photographer.
those
Yeah.
are those are David's pictures. He spends these days 6 months out of every year going out and doing naturalist photography. He's got traveling exhibits all over the country in this.
So there's been an enormous amount of technology development in the laboratory, as well as science, and that you always manage to intertwine the two to recognize when the technology was needed to solve a problem in the biology, and then when you had a new technology solution to apply it to the biology. So the laboratory's been a fantastic mixture of technology and biology and continued development. Is that a model that is something that you think is feasible anymore today in today's environment, with the privatization of patenting and all of that?
Well, I think it is still viable, that we have people who are still, come from the technological side, and they come and work with us. And the fax is a fantastic technology-biology interaction. In fact, complementary tools in immunobiology is what I've published papers on.
And Mario's right that it's a very interesting question, because the funding for that, as we pointed out, was your OIG grants, and I always had my biology grants alongside that. So we had funding to do it. I don't know if there's anybody with the insight to do this in today's genomics world, and B, whether anybody has the funding to bring in the kinds of people that companies can afford to hire. The market hires them out into companies really quickly. Everybody's dreaming of being the next .com.
Yeah, but I think that they still do it. I mean, actually, Mario, yourself, you are involved with companies and with CRADAs, which are collaborative agreements between biologists, NIH biologists, and the companies, Becton Dickinson people, and Mike Snyder, who's the chairman of a department and chairman of genomics, does have interaction between the two. We've got a lot of money which we got from patent royalties, and we use that to support people in the laboratory who have different technologies behind them, including biological technologies.
I just don't know the answer, Mario. I really don't. I mean, it only happened once in terms of if we look across everything we know about, that interaction between the engineers and the scientists in a biological, in a first-rate biology laboratory only happened here.
But it's
I
still
don't know.
happening.
And
Dave
it
Parks
is
is
Dave
still
is-
very much.
Still ongoing.
He's still
and
ongoing.
Wayne Moore, who's the
Right.
other half of that, is still ongoing. And we continue to support that these days out of our pocket because that's where it's going to have to be out of. But we continue to support that. But if it was something that could easily happen again, I would think by now it would have happened again. And I can't think of anybody's lab where this is happening again. There are a couple places here at Stanford where some people have done a little bit of it.
I think one of the reasons may be because of your philosophy that, society or the government or the United States paid for your science, and therefore the science that you generate belongs to society
People.
and belongs to the people. Nowadays, there's this push to patent things and then take it to a company and make $100 million off of it, or try to make $100 million. As I recall, on the original fax patent, you asked all of the inventors to sign the royalties back over to the laboratory
Correct.
and fund the laboratory. That's something that would probably never happen today.
That's right.
That's
And-
correct.
And by that was at that time in the 70s and 80s was one of Stanford's most valuable patents, and it was very generous, obviously, to fund the laboratory and provide ongoing support in that way. And I think that's something that sets apart the laboratory from many of laboratories of today, where the focus was really on returning to society the benefits that were accrued by their investment.
Well, we should take a good thought, full focus on patents and what's going on with patents today and what went on with patents before. There's some interesting history there. That Burt Rowland was the guy who did the Cohn-Boyer patent.
Molecular biology patent.
Molecular biology patent, the first really big biology patent. And around that time, Bernie Scher and I were talking a lot about should hybridomas be patented. And we came to the conclusion that no, they shouldn't be. And there are some very, very strong arguments for why it is really wrong to patent hybridomas. The strongest of which is that when you patent a hybridoma to do a particular job, if somebody comes along who has a better hybridoma, they throw it in the garbage because the first one is patented. And if you've got one with 10 times the affinity, forget it. No, the companies don't pick them up. These days, the companies are a little better about that. But the whole concept of patenting something that was a piece of biological material, a DNA sequence expressed as an antibody, seemed wrong both to Bernie, who was the head of BD, and he said, I don't think we have a problem commercially with selling reagents, that people will buy reagents even though they can make their own. That's not going to stop them from making reagents. Well, he lost. It cost BD $5 million a long time ago because he didn't believe in patenting things, and it was really a very expensive lesson for everybody. And Stanford pushes us to patent whatever we're supposed to patent. The government does. We have responsibilities with our grants. You're supposed to patent this. I still get this kind of feedback from Wayne. Put it in the public domain. It'll be okay. But it doesn't quite work that way, and it's a problem. So we do patent stuff. But I had a long running fight with Burt Rowland over that time about whether we should patent the monoclonals. And I took the position along with Bernie that we shouldn't do it, and he took the position as a patent person that we should do it. And of course he was much more in touch with the Stanford offices that eventually said we should patent this stuff. I don't know that it's right that any of these things that sequences where something better could do the job should be patentable as the thing that does the job. And this went back to the whole issue of how CD antigens were named. And I don't know if you know this, we were never part of the group that named CD, and that was because Cesar was still mad at me. As best as I can tell, he more or less ran who was going to be invited to those meetings, and he didn't want to. I don't think it's cost us anything in our career. And I think that we might have had a much better notation system had we actually had that as an open discussion rather than the way they did it as a committee. But that's yet another issue. And they shouldn't have been named the way they were named.
So just to close up a little bit, maybe you can reflect a little bit. Your laboratory, as I said, has been this mixture of technology development and biology. You have enormous accomplishments on both sides in terms of the biotechnology advances, in terms of basic understandings of immunology and so on. Where's your fondness? Where's your fondness? Do you more fondly remember the biological advances or the technology advances, or what is it that you like to hang your hat on?
All of it. I think I've had marvelous people who've come here, like you and like Vernon Hoy and like Gary Nolan and others who also, some of them try to emulate what I've done or what Lee and I have done or what Lee's done. And I think that the mixture is really what makes it really the witch's brew, if you will, stir.
Bubble, bubble.
Bubble, bubble, toil and
It's
trouble.
the people. In the end, life is with people. It's the fondness of all of the people who are here, the interactions. It's great to see, Nicole manages to get Peter proposed for a job. All this just keeps on going. And
I think that your job actually was recommended by Gary Nolan, wasn't it?
We all look out for each other.
Yeah.
And
we've had a number of social meetings which have gotten people from different parts of our life to be able to interact together, like Sam Black and so many of these fellows whom you know the names of, but maybe never met them but you meet them then because we have a birthday or we have an anniversary, we have a meeting, and people come together from different time periods.
I think the purpose of all findings is to be overturned. No?
Right.
I mean, so you can have a fondness for the work. I mean, I'm particularly fond of the B-cell lineage stuff, which I'm still working on, and we're actually getting there. But it's the people in the end, and the people that they connect to, and your real accomplishment in the world, I think, is in nurturing other people.
Have you heard of the book called Life is with People?
No.
Well, that's a book which we give out to people. That
get your coffee.
Margaret Mead wrote the introduction to it.
Uh-huh.
And it was after during the last parts of World War II, where the office of what became the CIA wanted to know what was going on behind the Iron Curtain, and they got people who could tell them, but they all turned out to be part of the same people. They were all Jewish, or they were, even though they came from different physical countries, I mean, Czechoslovakia, Poland, or Romania, Hungary, these people got together and had symposia and talked about their various backgrounds, and they all turned out to be, many of them turned out to be Jewish. And
well, what Margaret Mead said was that they had the experience of discovering a culture. They were anthropologists, and they had no idea that there was this whole subculture that existed amongst the parents of their friends and amongst the newly immigrated Jewish refugees who were coming into the country. And so they were interviewing everybody who came from Poland and came from these places. The vast majority were displaced Jews. And so they actually discovered the culture. But they named the book Life is with People because when they actually described the Jewish shtetl, which was the thing that they understood existed as the cultural center, the shtetl meaning small little town. And in describing that, they actually described the whole culture, and it exists today in lots of the Jews in this country, and probably in you for having spent 10 years with us. It's this transmissible recognition that buildings don't mean anything, places don't mean anything, money doesn't mean anything, but interactions amongst people, those will stay forever.
Well, and that certainly is a tremendous nucleus that you have built here of the laboratory and all of the people who have come through that laboratory, trained in the laboratory. And certainly for me, it's been an honor and a joy to be part of your greater scientific family.
Really nice to hear it from you.
So, thank you again for this conversation.